You need to stop getting into the belief that writing a paper will get you anything. It will, it may, but if you are publishing in some Q2, Q3, Q4 journals, in fact, it is negative. So, and if you are publishing in some upmarket journals, again, there are limitations. What matters is now is the time, and it's not going to last for too long. Now is the time to try and make not a product necessarily, make something which will get you a job and will help the society. Okay? You don't have to be the next Google. All you need to do is, if you can employ 3 people, you've done all right. You've done very well. Okay? You've done well for yourself. You've done well for the society, for the country. You're doing good. If you publish 3 papers, yeah, so what? I'm not saying don't publish, by the way. Okay? That's not what I'm saying. I'm saying publish if you have to. In fact, if you don't publish, there's a problem that people don't know you've got a technology which no one knows anything about. So, and do all of that. Patents, maybe. Most patents are not worth the paper they're written on. I know at the moment something which I disagree with the Indian government's strategy of publishing, making lots of patents. Most patents are useless globally, not only in India. And the other day I went to someone's office and they had 18 patents on the wall. I'm looking at them and I'm saying, okay, which of them has ever made you one paisa? Probability none. Again, going back to what Shiva was saying, make yourself useful. And that doesn't mean everyone has to become an entrepreneur, by the way. Everyone's got the different situation. I mean, if you do not have the temperament, don't. If you've got an immediate bills to pay and family to feed, you can't take that risk. You have to be in that situation where you can take the risk and you got the mindset, then you can do it. But interesting is nowadays, as you noticed, if you got the apps, you do not need a physical device. All of these things you can see can be, or many of these things, I won't say all of these things, many of these things can be done using watches, phones, laptops, etc., or even cheap little things that you can buy online. So you don't necessarily have to make a little widget, put it in a box, and pack it up and send it. You can make money, make a difference to the society simply based upon software itself. Okay? Sure. Am I going in the right path as where you were here? Now, whether EMG in sports is going to be the answer, I don't know. Maybe in that I might say EMG in the current form has got a lot of limitations. So whether that in itself is going to be the answer, may not. I do not know. Just because I do not know doesn't mean that it does not happen, but I do not know. But yesterday, if you remember, some of us were talking about coactivation. So what does and coactivation, the advantage of coactivation I was talking about was that it is not requiring exact signal quality. It does not require exact value of the muscle activity, muscle force, as you were talking about, or even fatigue or any of those things. You are literally just using it as a comparative between two muscles, which makes it, again, it has still got limitations, but it is likely to be more objective, more repeatable. So between 2 people, you can compare things. So now, what am I leading to? So coactivation in itself can become a feature rather than RMS, rather than where's the gentleman, that entropy person at the back? You? No, you were talking about the entropy, right? No, no, there was another person at the back. I think he's not there today. He's your student. He was talking about entropy and all of those. You can have all of those things. But in that, the more complicated the features are in general, the chances are that you need a very good quality signal, right? If you have poor quality signal, you're not going to get very good quality features, especially when you've gone through large number of mathematical modeling in that. So to me, coactivation is one of those features which is simple. So it'll work better even if the signal quality is not that good. So that's why I'm saying that is one option. I'm not saying that is the only option, right? What I'm saying is that with that as an option, you can consider other features of EMG that may be robust enough even when the signal quality is limited. Okay? Now, yesterday you all did the analysis of EMG yourselves, or did you? You did? When while I was enjoying the trip to a very old ancient temple, which I forgot the name of. What is the name? Huh? Sri Ganesha. While I was doing that, I hope you were sitting down and doing some EMG analysis, right? So now, and what you had promised me was that you are going to have two of you people present your observations of that. Okay? But before you do that observation thing, I want to ask you a couple of questions. And you can volunteer the answer. You don't, I'm not going to ask you one to the other. Which of these features are you comfortable with in saying, yes, this is something which I know was correct, was accurate, is repeatable? If you, your own money, had a crore rupees in your and a check, and you said, yo, this feature will work in something and the other one will not, which one would you put and say, yes, I'll give that check to? Any one of them? Any one of them? Maybe none, by the way. Anyone? No? That means the answer is you did not find any feature that you could say was repeatable. Is that, can I see a show of hands to confirm whether that was Shiva? You might find something on your table. So if you, does any of you have an opinion on that? Can you raise your hands to say you found none of them suitable? Is that a raise of a hand? No. Okay. You've given me a negative in both. Come on, you can't be doing that to me. Not on the last day. Which of them, was there any feature, anything that you did in the analysis yesterday, which said, yep, this worked? Hey, someone help me out, mate. Or if you say none of them worked, if you say none worked, that's okay. But then you have to make that statement. Okay? So validation has not been done. But as a gut feel, do you understand the word gut feel? Okay? From the stomach, all the breakfast and the lunch. Is there anything that comes out? Do you think that it is something which is happening, or you think it's not happening? As a gut feel, anything. Would you use it for force analysis, force assessment? Do you think you will? Huh? No. Okay, say so loudly. You've done your jogging in the morning. You got a big voice. Come on, say that. Oh, you didn't do that today. Baga. Okay. Anything else? What did you do? Anything which you think you would use for yourself. So he is not going to use it for force analysis of his own self. Would you use something? Would you use it for fatigue analysis?
I could use validated it.
Okay.
But something I am not sure that.
So you haven't validated it. Okay, I get the picture. But otherwise, when you were doing the analysis, and visually you can get a feedback. What is happening? What do you think? Was there anything in it? Huh? Okay.
With the shoulder extension that time only. So from this, I observed that triceps plays a very less role in extension. So that thing only I observed.
Okay. So you are able to use it to better understand. What are we seeing on the screen, by the way? What is that? Is it part of the university? Okay. So what you are saying is that it, from a educational research viewpoint, it has merit. So you are able to understand something about the muscle physiology of your shoulder because of what you are seeing. Is that what you're saying? This one? Say. So if you are a physiotherapist, which I know you are, and you were giving him advice, you could use that activity to determine whether his gym activity he's doing it properly or not. Is that the kind of feedback? Sure, that's interesting. I never thought about that, by the way, as an application, but now you're finding out new potential applications, right? Which are not based only on any of the traditional ones that we spoke about earlier, right? Very interesting. Anyone else came up with some interesting ideas when you were playing around with it? Actually, now I was generally it's a very interesting way of looking at it. Yeah. Because he is not doing his tricep activity. So yes, so that what is correct. So what it is done is what she has revealed is that by doing this, if someone was to go to the gym like he does, and then go to the physiotherapist who is an EMG expert, he will be able to, or she will be able to come to know the right thing and the wrong thing that they are doing. Fantastic. I mean, that is definitely a good application. So you, instead of talking about sports medicine like doing it directly, this is an indirect feedback which may be very helpful. So that's your. So is that going to be your PhD project? Why not? It looks like you got all the whole thing. You got the background. And now you got an idea, which seems to be now what you need to now. What does she need to do? Huh? Read papers, literature review, right? Because all of this ideas is how many samples did you take? One. A sample of one, right? Which can be very erroneous. Maybe it's a good start, but it is not enough. You need to find out what others have done. What is the literature talking about? Okay? If you only have a sample size of one, then it becomes like what the American president does, his own ideas, and comes crashing down. You need to understand the whole picture, right? Okay, now let's get started. Are we ready? Who is going to start? Which group should we start with? You guys? Who was the other representative? Were you? There's one more girl that was there, right? She's missing. There were three girls, right? Okay. So who is going to be your representative? It's your call. You are presenting. I am not presenting. I'm not telling you to any style. You have got a, do you have a PowerPoint? Okay. Okay, whichever way you want to do, I'll leave it to you.
So, based upon our analysis,
Guys, what's your name?
Delhi Raj.
Huh?
Delhi Raj.
Delhi?
Delhi Raj.
Dilly Raj.
Yes.
Dilly Raj is going to be telling us about their experience and their observations and everything else.
Yes.
Okay?
So, we started analysis on EMG signals for the 5 different subjects, our group.
Ma'am, please. The gentleman is speaking. Is his floor?
Anyway, in the first subject, we are just gone through the analysis. We are just finding that there are, especially in the biceps activity, there are a lot of noises are present, and baseline drifters are present in the subject one.
In subject one,
Yeah.
but not in subject two.
That's what I'm just saying one by
Okay,
one.
okay.
Okay. So as per the tricep activity is concerned, we are feeling that there are weak activities performed by the subject one. So due to which that so actually
Okay.
That subject data is not there.
Okay, doesn't matter. Well, the whole intention is it's a learning experience, right? So if you are if whatever we've learned, that is what Dilly Raj will tell us. Whatever you've learned, you will tell us. Okay, shoot.
Yeah. Okay. So as per my opinion, the biceps for the subject one is very weak in activation, and then unstable filtering is happened when we are analyzing his data.
Okay.
In the triceps is concerned, it has a very weak contractions.
Okay.
When doing the action. Then the subject two is concerned, that is also the biceps data is very noisy, and it has a valid spectrum of information, and there is an high energy of bands also is there in that data as per the subject two is concerned. So as per that, our opinion is it is very strong, and its stable contraction is maintained in as per the subject two is concerned.
So in for subject two,
Yeah.
the contraction was stable.
Yeah, for biceps activity.
Bicep.
Yeah.
But now you had two electrodes on the biceps, right?
Yes, sir.
So were both of them the same or were they different?
That is, we didn't change the position of the electrode, sir. We just have only one position.
Okay.
And,
And when you put the electrodes in one side of the end plate
yes.
to the middle, what happened? Was there any change you observed?
Yeah, we observed that change also, sir.
What was the
Actually,
change?
it is not activated properly. We are not getting the EMG signal properly. There is
Okay.
a lot of noises is coming.
Mhm.
And what exactly what we are experiencing for the activities performed by the person properly and placing the electrodes also properly, it is not done. It is not coming properly. We found.
Okay. We will now move. We'll do one thing. We are going to come back to you.
Yes,
Okay.
okay.
So we'll just go through everyone and then we'll come back to you. Who's the second group? Second volunteer group? You're not ready? The second group is not ready yet? No, if you're not ready, we can go to the third and come back to the second. You changed your seat today. Lucy, you changed your seat today by. Okay. So, is anyone presenting for you guys right now? No? Third group. Are you sitting as per your group? Guys, I have a flight to catch soon. And some people have to go at 1:30 train to not Trivandrum, what's the thing called? No, not Trichy. There's a place in Andhra, the Vishakhapatnam. Right. You're going to Vishakhapatnam at 1:30. So we have to hurry, guys. He'll miss his train otherwise. Okay, group 4, anyone there? Who is your representative in group 4? Okay, anyone here? The Vishakhapatnam man? Are you guys ready? Present? Yes, no? Who is your, are you the speaker? Who is the speaker? You? Come on, okay, let's do one thing. 5 minutes. Can we talk to our group within 5 minutes and identify who's going to speak and let's get ready? Okay? It started off so well in the first group, and then after that, it's all up. Mike? Okay. There you are. Can you pass it on to it? Okay, there we are.
Sir, first of all,
I think I know their relationship. He goes to the gym, you go to the gym. So,
it's not about gym, sir.
okay, let's hear.
Sir, actually,
Guys,
I don't know whether I have done it correct or not.
doesn't matter.
My observations is correct.
Absolutely correct. We are asking you as a group representative what you did and what was your observation.
Okay, sir. The initial.
And you are not presenting only you, you're presenting the group.
Yeah, sure.
Okay.
Sir, initially, we have got 5 data sets, S1 to S5. And in the first data set, actually 3 columns was there. And in 5 columns was there. In that, the 4th and 5th column was we were instructed to take it for the analysis. And the rest S2 to S5, that means sample 2 to sample 5. It was instructed earlier. It is 2nd and 3rd column, in fact. But the 3rd column was RMS value. I think so. So we shifted to 1 and 2 by looking into the data, because we can see the minus and plus value, so that we can see the zero crossing rates and all.
Yep, I'm listening.
Yeah, and from then we have done the analysis as per the instruction, and that's what I was telling. The muscles, the channels.
Guys, someone speaking.
The muscle was not explicitly mentioned in the data set. So which channel represent which muscle was not mentioned.
Okay.
And the activity is also not explicitly mentioned.
Okay.
So from the with reference to that, it was difficult to analyze initially. So what will be the pattern of the the what the data will be inferring into. But
Okay.
we have done the feature extraction and the spectrum analysis and all. And from that, what we understood is that for the subject one, the motor units was the normal recruitment with the good signal capture. That was because it was a smooth action without load. It was. And for the sample 2, there was a frequency spike in the spectrum, so which may be lead to the electrodes positioning issues or baseline offset issues. And from the third subject to fifth subject, it was almost the results were nearly the same. So the muscle activity was stronger, it leads to the to the physiological aspects. The longer muscle length is there, maybe there, the greater recruitment of muscle fibers will be there with load. So that may be the experiment with load. It may be. So this was the inference. Not inference, observation. I cannot say it as inference.
Okay. Anyone who wants to change, add? Give her the microphone, please.
We did spectral analysis on the raw EEG signal, where we could find the peaking of power line interference.
At 50 hertz?
It's 50 hertz, sir.
Which means that there was line noise.
Yeah.
Right? Okay.
So that after denoising, we suppressed it.
Okay. So if I was to sum up what you guys were saying, one was a generic problem that you had, that your notes did not correspond to the samples, or you did not take the notes properly, right? Which, while we were in a hurry, we did all of those things, so I can understand that. But it also tells you that not in this context, but in any context, if your experimental design is not accurate, the protocol is not accurate, or protocol is quick and done, then such problems will happen. Okay, and that is not limited to EMG. That is anything. That is life. Even in life, if you do not have a protocol, you're gonna make a mess of life. Second is that you observed large differences between 2 or 3 people. All right, which makes it that whatever you are doing with EMG and the biomechanics of muscle, you have to be mindful that you are going to get differences between people, which means that your applications are going to be highly limited, right? So that is the second observation I would say out of what you said. I think the third that you are saying is that you observed that there was noise, but line noise, but however, you are able to overcome quite easily. So and with the new equipment, line noise has become much better and easier. So I think, can I say that these are the 3 main observations that you did? Anyone? Anything? You want to add to that?
Case of spectrogram analysis, we could find the co-activation muscle,
Okay, and how did that happen?
because there was an overlap between the time and frequency.
Between the time and the frequency of the 2 different muscles.
Yes, sir.
Okay, so there was a co-activation happening, but was it in all cases, all people?
Subject 4, I could find. I was doing that.
Okay, so again, she then had a look at and found the idea of co-activation is possible. Okay. Next volunteer. Anyone here? No? You guys? Anyone here?
So experienced with that. This is the first time.
Sure. So that means this was the first time you experienced with actual hardware and actual signal.
Yes, sir.
In the past, you got some signal from somewhere which you do not really know, and you've done some analysis and you got some results.
Yes, sir.
Right? So when you are doing it in real,
Yes, sir.
you observed that it is not as simple as it was when you got it from online. Is that a reasonable statement? Okay. Anything else that you observed when you did the analysis? So one was the actual signal quality. I'm guessing that that's what you're referring to. Correct?
Quality.
Anything else that you want to tell? Guys, what when you got the results, what all things did you observe in that signal? Give him the mic. I think he's got him. You want to speak? Okay. Why don't I do one thing? I'll come back to you in 5 minutes. You guys ready? Who's your speaker? Okay. And you guys are separate groups, right? Okay. Okay, let's hear your voice. You can keep sitting. You don't have to stand up. Unless you prefer standing up. So what?
Sir, in our team, we analyze one data only, sir.
A bit louder, I think. Huh? No, you speak.
In our team, analyze one data only because MATLAB software can't use first because it's first time user this.
Okay.
So I share one small information for S5 data.
Okay.
Triceps muscles show stronger activation, higher power, and more frequent concentration compared to triceps, sir.
More?
Biceps and triceps compared to biceps is more active.
Yeah, but so his biceps or whoever biceps were more active and
Yeah.
triceps were not active.
Yes, sir.
Okay?
Yes, sir.
Right. What else? Did you what other any other observations when between you only did one person?
Sir, in our data you give only one data I analyze, sir, because I not
Okay.
MATLAB. Sir.
Okay, so it was and what about you guys? You did the same thing or you were
4 members are same.
okay?
Sir, the team leaders.
Huh?
He's the team leader.
Who's the team leader? You? Okay. You were the team leader. Okay.
Sir, hello.
Yep.
So some activities means concentric and eccentric person.
Yep.
So during that, biceps are more dominant and sometimes triceps are dominant.
Okay. So your observation was that they only did one person's data and they found that this person, he or she, has got a strong bicep and a weak tricep. Is that an observation, at least based upon their EMG recording, right? And they also found that because they are not familiar with MATLAB or the signal, this was an experience to use MATLAB for this purpose, right? You guys, who's the lady in the black? Are you the one? No? You? Okay.
Good morning, sir.
Good morning.
Sir, we recorded EMG signals for the biceps muscles
Okay.
only, sir, using MATLAB. Using MATLAB, we successfully filtered and analyzed the EMG signals of the biceps.
Okay.
The results clearly demonstrates the difference between rest and contraction.
Okay.
And how signal processing reveals meaningful physiological information. The EMG data was stored in multiple columns where each column represented different signals recorded during acquisition. We extracted the fourth column data because the fourth column data represents the biceps muscle.
Okay.
So we done that only, sir.
Okay.
That's
What
it,
about
sir.
movement artifact? Did you see any movement artifact?
No, sir.
When you did with no activity, did you see any activity?
Yes, sir. I saw some noise, sir. Noise
So
artifacts.
that is artifact,
Artifacts.
right? Okay. Thank you. So how would I summarize what these guys did? I think it is coming out to be that some of you guys who have not used MATLAB before. Which group were you with? This guy at the back. So she skipped the thing, right? No certificate for her, right? And I said no certificate for her today, right? Now, what they observed is that I think the commonality one was that MATLAB in itself, learning for a person who never used it before, is a learning experience. And then they're also finding, I think another commonality appears to be that biceps seems to be more active. And lastly, it was that there was motion artifact when the muscle was when there was movement without any load. Is that a reasonable thing? Are these three observations on your behalf? Okay. Anyone else? You guys are done. Okay.
Good morning, sir.
Good morning.
I'm Shalini. Yesterday is my first day to use the MATLAB. So I learned for that quickly using ChatGPT. And thank you for that. And this I analyzed the output first time in MATLAB, and that's a great
Achievement.
motivation. Yes, sir.
Fantastic. I am delighted. Okay.
And also we analyze the biceps and triceps of various samples, and we also analyze there is a motion artifacts. That's it, sir.
Now, okay, so because you've done it for the first time, but according to you, how many people this data did you do? Only one or more?
Sir, more.
Okay. How much was the similarity and differences between two people? When you did yours and his or something, was it same?
No, sir. There
Okay.
is a
What is the difference?
Sir, I think there is a strength difference.
Okay, the signal strength
Yes,
is
sir.
different. Okay, what else? In noise, similar,
No, sir.
different.
Yes, a noise also. It's
Okay. And any other differences that you saw? Was the spectrum similar? Did you do spectrum analysis?
Yes, sir.
Okay. Was the spectrum kind of similar? Anyone? Come on, help her out too. She's being. You all did the same thing, right? So tell her, yes, you all guys can help her out.
Sir,
Anything else that you would observe? No? Okay.
yes.
Thank you very much.
Thank you, sir.
I am glad to hear a newbie now. Anyone else? You? Someone in your group? Who's in your group? Come on. No. Huh?
Same.
Which same? But they haven't. Okay, so you can do it together. So you want her to speak? Why can't you speak? Okay, we won't do that right now, ma'am. You can put it closer. You know one thing? You know what? When you get a job, you will need to speak. Might as well start doing it now. In here, you make a mistake, it's okay. In a job, you won't be allowed to. Okay, guys.
Good morning, sir.
Good morning. And what's your name?
Anuprabha, sir.
Anuprabha. Anuprabha. Hi, Anuprabha.
Actually, we've done a We done a MATLAB program yesterday only to get output. It's a first time experience.
Okay. We've already given a clap to her, so we're not going to do it again.
Okay. Actually, the comparison between raw and filter EMG.
Mm-hmm.
The raw EMG has more noise. More noise.
Okay. So that means the pre-processing was very important. Okay.
The filter EMG is more consistent and clearer pattern, sir.
Okay. I'm listening.
And then EMG signal is likely being used to measure the electrical activity.
Repeat again, please.
EMG signal is being used to measure the electrical activity of the bicep muscle.
Okay. So what happened then? Was it
And the filtering process have been applied to remove noise.
okay? Okay.
Sir, that's it, sir.
Fantastic. Anyone else? No, thank you.
Thank you.
Who is the one in your group? Which group are you guys? You can't be a 10 people group, are you?
Good morning, sir.
Good morning. What's your name?
My name is Sanjay AK, sir.
Ajay.
Sanjay AK.
Sanjay.
AK, sir. It's my
Okay.
initial.
Sanjay. All right.
Yes, sir. Sir, yesterday I learned in MATLAB how to upload a drive to MATLAB. How to upload a file to MATLAB.
Okay. First time?
Yes, sir.
Okay. Again, so first timers are getting the clap.
Yes, sir.
Okay.
And I got output with the EMG signal, sir.
All right. And what happened? What are your observations?
Sir, I observed, sir. Sir, I observed bicep signals, sir.
Uh-huh.
Bicep signals.
Yep.
Sir, that is with the noise and without noise, sir. I
Okay.
filtered both.
So you also talking about the pre-processing?
Yes, sir.
And did you find the pre-processing very important, not important?
So if we filter, the output was it's in correct form, sir.
Okay, so pre-processing was essential.
Yes, sir.
Okay. What else?
That's all, sir.
That's it. Thank you.
Thank you.
Guys, you already did. You did, right? Your group? Okay. Can I get the microphone, please? Okay. Folks.
Hello, sir. And based on our findings, we have found.
What's your name, by the way?
Sir, I'm Tanishka.
Tanishka.
Yes.
Hey, Tanishka.
Hello, sir. Based on our findings, the power spectral density was higher at lower frequencies.
Okay, so in other words, it was like this.
Yeah, yes, sir. It was like that.
And where was the peak coming approximately?
Sir, around, sir, 50. Sir, between 50 to 100. Yeah, somewhere around 50 to 100.
50 to 100. Okay,
Yeah.
that seems a bit high.
Yeah,
It would be normally lower. But okay. Huh?
so between 50 and 100. Like.
Okay. Okay,
Sir,
what else?
Then at higher frequencies, the energy is in terms of microvolts.
Okay.
Very low.
Yep.
Microvolt square.
Yep, good.
Okay. And power line interference is low. So the electrode placement was good based on the observations.
Okay.
So, and the filtered EMG signal showed dominant activity in 50 to 150 hertz.
Okay.
And above 400 hertz, the signal detection was less, sir. So
Okay.
typically it lies between 10 to 500, and above 400 it was less
Okay.
comparatively. And the variance was 0 for subject 2, 3, 4, and 5. Only we got variance for the first subject.
What was 0?
Variance is 0.
Okay.
And no muscle fatigue was found in the recording, sir. So the EMG recording time is longer.
Okay?
Yeah, based on, yeah, need to be longer for better analysis. And this is our findings.
Okay, good.
Analysis. Yeah.
Now, I have a feeling that while your observations are correct, your numbers are not correct. Okay? And that may be because when you are using, you use Python or MATLAB?
MATLAB.
MATLAB. In MATLAB, maybe the sampling rate that you gave might have been different.
Yes.
Huh? 2000. Well, I don't know then because somehow your peak should typically be in the range more closer to 40 hertz. And when you do the assessment, your normal surface EMG of the bicep would have nearly gone to pretty close to zero after about 80 hertz or 100 hertz.
Okay.
So my take is that somewhere around there, and these are not based, these numbers may be based upon some parameter that when you were entering, when you might have done a mistake, whether it's a sampling rate or anything else, I do not know.
Okay.
Yeah. If it's 1,000 hertz, obviously, then whatever are the numbers, yes, you are halving everything becomes half. So all of that could have contributed. But yes, thank you very much. That is great. And you are the last guys. So, okay. Yep. What's your name first?
Angudashni, yes, sir.
Angudashni. Okay, Angudashni, please. What does Angudashni mean? Just for curiosity.
Grandma's name.
I know, but it has to mean something. My name is Dinesh, and it means the giver of light. Like a teacher, like a. So I can tell you my name's meaning. Angudashni. I'll find out later. Okay.
Took sample too, sir.
Okay.
In MATLAB.
Okay.
As we don't have laptop in our hand, we just executed in the lab sample two only.
Okay.
As per our output, our horizontal axis is time progression, sir, and the vertical axis is frequency of 0 to.
Guys, I can't even hear her. How can you hear her? Yes.
1000 hertz, sir. Our color density in the output is bright yellow or red, which gives a high power, sir, and the dark, which gives the low power, sir. That's it.
Was this the first time that you did MATLAB?
Yes, sir.
Okay. So now, well, why don't we give you a clap for doing the first time? Right. So obviously you have to do a bit more analysis on this before you can come up with some answer, right? I hope you continue doing that. Now, is there anyone else you want to do? Any observations that have not been covered? Sure.
Like that, we can disconnect.
Okay. So if you want to know, okay, that's another way of doing it, right? Okay, now, a couple of things that you have observed in this entire exercise. One was that there are large individual differences for people who've done analysis on multiple people. The second one appears to be whoever have been able to do the repeatability assessment, that the repeatability was questionable. Pre-processing was essential for taking the quality of for making the signal worth doing. And while line noise was not observed by everyone, but many of you people felt that in some cases at least line noise was more than the other. And some of you also observed that that was perhaps because the electrode placement. So if you place the electrodes properly, line noise was not there. If you did not place them properly, then the line noise was there. Third, and one more thing was, when talking about electrode placement, you also have observed, some of you at least, that if you had the electrode placed over the end plate, your signal quality was bad. If it was on one side of the end plate, the signal quality was good. How many of you did that? I know you did that. Who else did it? I know you did not. Anyone else or only you? No one else tested the difference between electrodes in the center and electrodes on the side? You did that? Okay. Okay. But did anyone do that observation? Oh, okay. Now that is a problem. Okay, okay, okay. So this entire thing can then be considered an electrode placement. On a different note, it appears that many of you had also observed that biceps of most people in this data set was stronger than the triceps. Now this, I cannot make you a statement whether that's true or false, because all we are doing is we are basing it on the electrodes, on the EMG. And we do know, as you have mentioned, I think you have mentioned, that because there are so many other factors which go into it, and I think the people at the back also mentioned that we cannot make a genuine statement whether that is true. All we are saying is that the signal recorded from one based upon the electrode placement as etc., seems to suggest this observation. Okay? So what have we learned out of this? And yes, one last thing which I observed was that it appears that MATLAB is easy to use, but even though many of you had not used it before, I did not know that. I thought everyone knew Python and MATLAB. So even though you had not used it, you were able to get on top of it very, very quickly. So impressed. That was an impressive work on your part. Okay, any other observation that you have? Yep. Microphone is.
Hi, Manikandan, sir.
Manikandan.
Sir, the changes in the recruitment of biceps to triceps, sir, that movement, we are extending the triceps now. So that is not the proper movement to analyze the activity of the triceps. Biomechanically, extension of the tricep behind the shoulder makes the maximum recruitment. So just relaxing the bicep muscles may tend to the extension of the tricep. So that's why the variations occurs larger, sir.
That is why I did not mention that here. I said this is an observation by you guys. Whether true or false, we do not know, because there are lots of unknowns, because the protocol was not designed, because all of those factors are there. So I did not make that as an observation. I'm just saying it was an observation, right? True or false, I cannot tell you. Huh? Yep.
Elbow against the gravity all the time for all the activities, eating, mobile. So we are moving we are moving our elbows, that is bending, which is responsible, which the biceps does. So that biceps we are using throughout the day against gravity. It has to move the limb against gravity all the time, doing all the work, even though we are not going to the gym and all. So the triceps, it is assisted by the gravity, what I said. So it is assisted by the gravity. Most of the work, as he said, gravity does. So we don't have that much bulk in the triceps. That may be, from my perspective, that is, I'm analyzing it like that may be the reason for this kind of changes in biceps.
Sure, but it's
And the
also,
other thing-
I mean, I'm not saying you're wrong. I do not know. You see, tricep is a three-headed muscle. Or the shape of the muscle in itself, the placement of the electrode, all of those things could contribute towards it. It is also, maybe what you are saying is that we are working, doing this activity against the gravity and releasing it. So I'm not saying you're wrong. I'm saying I do not know. Okay? And what you are saying makes logical sense to some extent. But again, not being an expert on that, I cannot tell you. So, any other observation you think? Now, yes. Oh, I thought you had, oh. Okay. Now, in case if no other observation in this situation, now consider where have this all taken us to? See, muscle is important, skeletal muscles are important, and we have and there are lots of problems which are coming up. Right from the way our posture is, to an aging population, to other factors, to the lack of exercise and things like that. Go on. So muscles play an important role, and disease conditions are coming up. New disease conditions are coming up with muscles. Again, as engineers, we are trying to fix things by trying to make tools and robots and prostheses, etc., to do something in that matter too. Whether now EMG is one of the tools that was identified many decades ago, and it seems to identify some amount of activity of the muscle. I think looking at what you have told me here, a common observation is that it has got lots of limitations. It is easy to use. Sitting down on nothing with an equipment which you could build in a few thousand rupees, and your laptop, you can do the analysis, and in 2 hours you learned how to do it. Very impressive about that, but that is all there. But so it's easy to do. Okay, what are the limitations? Well, there are plenty. Some of the observations, like what? I'm sorry, I didn't get your name, ma'am. Poonam. Bhavana. Bhuvana. So my apologies for mispronouncing it. Bhuvana. Okay. So what Bhuvana pointed out, that there are potential other applications that we didn't explore, like what we were talking about, Whether that is correct or not, I do not know. What I'm trying to suggest to you is that it is a tool which was developed at a time, does some activity, whether that is directly related and has got an application to what you guys are doing, you have to figure out. Maybe you have to think outside the box and identify some other potential applications, all right? And obviously, you can use all of these things for limited purposes, depending upon how much of automation you want to bring in, how much of whether it is a visual observation, like you said, as soon as I put it on, I can observe that the signal is going up. So that kind of a thing is fine. What I am trying to suggest to you is that now that you've got a better handle on it, determine if it has got an application which you want to do, and what are the things that you need to do about it. Just because someone said EMG and you thought, oh yeah, it sounds all right, it doesn't mean that it might be okay. It may not be okay for your work. You have got lots of limitations, but it has got potentials. Okay. Other thing is, we understand a little bit of the muscle physiology. Knowing that, can we invent a new measure altogether? Someone did put 2 electrodes across and call it EMG. Maybe you can invent a new measure of what is happening in the muscle. Nowadays, you got so many more sensors available easily. You were talking about gait. You're talking about lip movement. Someone was talking about lip. Who was talking about lip movement? The EMG or the facial? You? Okay. So if you got alternates now. A video analysis can be used. Again, where do you want to use that facial EMG? Question. So again, EMG by in itself may have limitations. Club it with things like IMUs or some other sensors or video sensors, you suddenly may have a potential. Okay? So a point I'm trying to lead down to is there is potential usage. There are limitations. Find out how, by doing some kind of a data fusion, can you overcome the limitations and figure out whether you want to use EMG at all or not. Think outside the box. Okay? That is, I think, from my end, more or less it. If you have any questions now. I need a coffee, hopefully coming soon. Besides, in how much time coffee is coming, any other question? No? Nothing? Take a microphone, please. Because I think they want to record it onto their system, whatever. Where's the microphone? Walked away. With injury. Okay? Okay. Now, what Nuzi was asking about was, Nizu was asking about was the use of EMG to detect falls or prevent falls. And that is used for the gait analysis. So while there are many projects in such areas, one of them is related to, the one which I'm aware of, is related to something called freezing of gait. Now, in this is typically a neuro problem where people, when they're walking, typically the ones who have got a compromised basal ganglia, end up stopping in between, and when that happens, they can fall over. So one of the ways of doing with this situation is physiotherapists right now, in order to overcome freezing of gait, try to make the people work the muscles harder. When that happens, often the opposite happens. The muscles get fatigued. And so instead of preventing falls, it actually can cause falls. So one of the factors which in this case happens now for freezing of gait is that you can identify if which muscle is co-activating, the two muscles are behaving together, which can cause a freezing of gait. Is it a muscle weakness which is doing it? So trying to go into the whole process of what is happening. So we know that the basic thing is happening at the brain level. At the superficial level, which muscle is involved? And by doing that, we might be able to help a person target their exercise or relaxation training. So that's one application that I know of. You can also do EMG for the purpose of determining whether a person is swinging properly. So if sometimes a person may be doing that incorrectly, and that can lead to difficulties in the gait, which can again lead to either fatigue and falls. So these are some of the points that I could again, in freezing of gait, we have done some work, but there's a large body of knowledge out of the University of Haifa in Israel who have done some excellent work here. I would recommend, if you are looking at something, that's the place to start. Then what else I could then again, you also have for the same thing for the elderly, to train people who are frail to overcome their to increase the torque at the ankle. Often we do is that physiotherapists would train them to activate the muscles. With the frailty, however, that can backfire, because when you are training people to overactivate the muscles and they're frail, they fatigue very quickly. So something like what we do normally will make them fall down because they're just frail and fatigued. So again, targeting which muscle to be trained and which muscle to be relaxed is something that can be identified. And I think there is potential of working in that area. But again, we have to be careful in the limitations as we discussed earlier. That's all I can say. Okay. Any other questions, guys? Yes?
Any training is needed, like artificial neural network like that.
You can put our AI and thing into anything. So all you're doing is you are finding out some ways of identifying the properties of some features and some relationship of the features. That's one. You can also use AI for right from the pre-processing and the filtering, right? You could also use things like ICA. Are you familiar with ICA? Independent component analysis. So you could, that's also an AI-based tool in order to improve the signal quality and other things. So yeah, you could throw AI into anything, right? Intelligently or non-intelligently. AI will do something. Sure.
Sir, you said you are working on prosthetics, no, sir?
I was.
Or you were continuing, or you?
Pardon?
Are you continuing that? Or?
No. As I mentioned last time, that there are so many variables and other things, and I think it's a waste of time. So I've written, you can see my paper on that. It's in 2019, Kumar and Gels. You can see it's in, what's the journal called? BSPC. Okay. For upper limb prosthesis, I would definitely not recommend. Other than, but I know people are gonna do it. People are doing it. It sounds sexy. Go with it. Okay. And I think there's another thing I was reminded. Excuse me. I think you were supposed to be running a feedback or something about the thing because Karthik wanted that. Do you know anything about it? Okay, so you can get that organized. And I believe that at 12 o'clock, you guys are going to be, there's going to be some kind of a ceremony. Pardon? Okay, so that is also going to happen. And anything else that I know of? And if you have any questions, you can ask now or later about the universe, about Kaveri Dam, about EMG, anything. Feel free. Or about the origins of upma. You know where upma comes from? Have you eaten upma? You eat upma? Huh? Pardon? You hate upma. You hate upma. Okay. Anyone else hates upma here? You hate upma. Okay. Then why do they give it so often? Huh? You hate upma. Okay. And how many love upma? Sorry, you are in the minority. But do you know who invented upma? How old is upma? How old is the tradition of upma? It is less than 100 years old. It was invented, not originated. It was invented on behalf of the English, who had taken rice from here to their soldiers during the First World War. So there was no rice. So you were given wheat from the north, and you guys did not know how to make roti. So this was the closest that they could do of using wheat or something similar to rice. So that is how the upma was invented. Huh? Yeah, 1920, thereabouts. Okay, how many of you drink chai? Chai. Do you know where is the chai from? Where is the chai from? Someone? Assam, Iran, China? Anyone? Tibet? Huh? China? Assam? Anyone? Different? Yes, it is from China. Yep. But China, in even today, though, but the concept of putting milk into chai, that was by the English. Because we in India used to like to drink kava and more. Huh? Like green tea. No, but it's made from walnut leaves and cinnamon in winter. So in order to do that, we're talking about tea, origin of tea, or origin of chai. So and the English put milk and sugar and all the spices so that they could sell us chai. So it's only 100 years old. Sambar is also not Indian, by the way. Many of these things. Sorry.